and more dynamic than the last. For many, it was the most vivid comet they had ever witnessed in their lifetime. Professionals, too, were stunned. Some admitted that comets of this scale were supposed to belong to the history books, not the 21st century. The sheer brilliance of Swan set off not only excitement, but also deep unease. Objects this bright, this visible, are supposed to be rare once-in-a-generation events. Yet Swan had appeared suddenly, seemingly out of nowhere, and it was only getting brighter. The question wasn't just how large it was how such a titan could sneak into the inner solar system without warning. As astonishing as Swan was on its own, it didn't arrive alone. Just days before its discovery, astronomers were already tracking another object, 3IATLAS, the third confirmed interstellar visitor to enter our solar system. Atlas had been inbound from a completely different sector of the sky, tracing a path out of Sagittarius, while Swan came diving in from Aquarius. On any star map, their entry vectors are separated by more than a quarter of the celestial sphere, about as far apart as you could imagine. And yet both objects are set to swing past the Sun almost simultaneously. Atlas reaches its closest point on October 17th, skimming in at about 203 million kilometers. Just 3 days later, on October 20th, Swan follows, diving even closer at around 150 million kilometers. That places their perihelion points just 50 million kilometers apart, closer than the average distance between Earth and Mars. For astronomers, this was a jaw-dropping coincidence. Normally, the arrival of bright new objects is scattered across months or even years. But here, two of the most remarkable bodies of the decade are converging on the Sun within the same 10-day corridor. It is a double event so precise, so tightly choreographed, that chance alone feels inadequate as an explanation. It was no longer a question of Swan or Atlas. It was Swan and Atlas. Two strangers from different corners of the sky, both arriving together, both heading for a close pass at the Sun in October 2025. When astronomers mapped out the trajectories of Swan and Atlas, the geometry stunned them. Both are on steeply tilted orbits, approaching from completely different angles. Swan at over 60 degrees off the ecliptic, Atlas nearly perpendicular to the plane of the planets. By all accounts, their paths should have had nothing in common. Yet somehow, both will reach perihelion within days of each other, at almost the same solar distance. If that wasn't unlikely enough, the timing adds another twist. Their closest approaches happen during what's known as a solar blackout window. From October 8th to October 18th, the glare of the Sun blinds Earth's telescopes, making direct observation of these objects nearly impossible. And right in the middle of that blackout, Atlas and Swan converge to get two bright, anomalous objects arriving from different corners of the sky, hitting nearly the same distance from the Sun, all within a window when Earth is effectively blind. The odds of this happening by pure chance are vanishingly small. Even the most skeptical astronomers admit the alignment feels more like choreography than coincidence. That's why talk of coordination, or even engineering, has crept into scientific debates. If these are natural comets, the universe has dealt us an astronomical coincidence beyond belief. But if they aren't, then their synchronized arrival could be part of something far more deliberate. While Swan looked every bit the part of a classic great comet, 3IATLAS quickly proved it was anything but ordinary. From the first spectrographic readings, astronomers noticed something disturbing. Normal comets are dominated by water vapor and dust, with traces of carbon compounds. But Atlas lit up with a nickel-heavy signature, a metal rarely seen in such abundance on icy bodies. It was as if the object carried an artificial alloy rather than natural cometary ice. Then came the gas emissions. Atlas vented enormous amounts of carbon dioxide, far exceeding what physics predicted for its size and distance from the Sun. Instead of the usual gradual increase in activity, its outgassing surged in sharp, sudden bursts, like an engine throttling up, rather than a frozen surface thawing in sunlight. The biggest shock, though, was its motion. Careful tracking revealed step-like accelerations. Atlas wasn't smoothly drifting under solar radiation pressure. Instead, it would hold steady for days, then suddenly shift its velocity in distinct jumps. To some, it looked eerily similar to controlled thrust maneuvers. Mainstream scientists urged caution, but whispers spread quickly. Was Atlas behaving like a comet or like a probe? If Oumuamua in 2017 raised the first questions about artificial interstellar objects, Atlas was doubling down with evidence no one could easily dismiss. The most unnerving detail about Atlas isn't just that it accelerates, it's how much energy those accelerations require. When researchers crunched the numbers, the thrust wasn't trivial. To shift a body tens of kilometers across through space, against the pull of the sun, takes staggering power. Initial calculations suggested the equivalent of 10 full-scale nuclear power plants operating simultaneously, sustained long enough to produce the sharp, step-like velocity changes we've observed. That's not random venting of ice. Natural outgassing simply cannot deliver that kind of controlled impulse, not in bursts so clean, so discrete, and so repeatable. For comparison, even the brightest comets in history, Hale-Bopp, Halley, Hyakutake, showed outgassing jets that were chaotic, messy, and uncoordinated. Atlas is different. Its thrusts appear deliberate, as if timed, as if guided by something beyond simple physics. That left scientists with two unsettling choices. Either we are witnessing a completely new class of interstellar object with mechanisms unknown to science, or Atlas is not entirely natural. The idea that its movements could be powered, perhaps even piloted, moved from the fringes of speculation into mainstream debate. If the energy truly matches that of nuclear reactors, then Atlas is less like a comet and more like an engine, one hurtling straight into the heart of our solar system. If Atlas raised alarms, Swan pushed the mystery into an entirely new league. On the surface, it looked like a comet, a blazing tail, a glowing nucleus. But as observations sharpened, details emerged that didn't belong to any natural body. Spectroscopy hinted at a nickel-cobalt composition, metals more often associated with engineered alloys than fragile, icy rubble. Surrounding Swan was not just a dust halo, but something stranger, an electromagnetic-like sheath, a field that seemed to deflect charged particles streaming from the solar wind. No known comet has ever displayed such shielding behavior. Even more baffling were Swan's bursts of energy. High-resolution monitoring picked up plasma-like pulses firing from its nucleus at regular intervals, propelling material outward in rhythmic waves. These weren't the chaotic, unpredictable jets of sublimating ice. They were timed, almost mechanical, resembling the steady rhythm of an engine cycle. Astronomers began referring to Swan not as a comet, but as a fortress in space, a massive structure cloaked in cometary disguise, armored and actively sustaining itself as it moved deeper into the solar system. The conclusion was unnerving. If Atlas looked like a probe, Swan looked like a battleship, a construct whose presence was not accidental, but intentional. When astronomers traced Swan's orbit backward, what they uncovered added yet another layer of intrigue. Swan's orbital period was calculated at roughly 22,554 years, a cycle so vast it stretches across the rise and fall of civilizations. This means Swan may have visited Earth's skies during pivotal turning points in human prehistory. The last time Swan swept through the inner solar system, Earth was locked in the waning stages of the last ice age. Vast glaciers still dominated North America and Europe, and human societies were beginning the slow shift from nomadic life to permanent settlements. Some researchers point out that this timing overlaps with the Younger Dryas period, a sudden climatic shift marked by unexplained cooling and catastrophic environmental upheavals. The coincidence doesn't stop there. Roughly the same era saw the construction of Göbekli Tepe, the mysterious stone temple in modern-day Turkey, dated to around 11,000 BCE. Its intricate carvings and celestial alignments have long puzzled archaeologists. Could ancient skywatchers have recorded Swan's previous return, encoding its passage in their monuments? The suggestion is bold, but the resonance is hard to ignore. A cosmic visitor with a 22,554-year cycle, reappearing in moments of profound transformation for Earth. If Swan's last appearance coincided with the birth of civilization, what might its return herald now? With Swan and Atlas moving in tandem, speculation turned from what they are to why they're here. Theories range from cautious to chilling. Some astronomers propose Swan could be on a solar refueling mission, using its vast halo to capture and store plasma energy during perihelion, a feat no natural comet could achieve. Others suggest Atlas may act as a data courier or probe, exchanging information with Swan in a coordinated maneuver, like spacecraft meeting for a handoff. A darker possibility is probe recovery or even conflict. Atlas, smaller and more erratic, could represent a damaged or expendable scout. Swan, armored and fortress-like, might have been dispatched to retrieve or neutralize it. Their near-simultaneous arrival, in this view, is no coincidence, but a planned rendezvous. Then there's the unsettling theory of an audit chain, a sequence of escalating responses triggered by Earth's own signals. Ever since we began broadcasting radio into space a century ago, culminating in the radar pings that revealed Oumuamua in 2017, we may have been flagged by an interstellar network. Swan and Atlas could be successive stages in that chain. An inspection, a report, and now, perhaps, enforcement. Whatever the mission, one fact is undeniable. Two anomalous objects, arriving together, executing maneuvers that look deliberate. The solar system has become a stage, and Earth is no longer just an observer. It is a participant. As Swan and Atlas approached their closest point to the Sun, a new challenge emerged, not from the cosmos, but from human institutions. Major space agencies, including NASA and the European Space Agency, quietly imposed observation blackouts during perihelion. Ground-based radar, high-resolution imaging, and most public telescope access were restricted, ostensibly for safety during solar conjunction. Requests for raw data were rerouted, delayed, or denied without explanation. This left a critical window, October 8th to 18th, where the sun's glare already made observation difficult, now compounded by official silence. And yet, humanity refused to look away. Amateur astronomers, backyard observers, and independent networks rallied. Veteran tracker Bill Gray coordinated a distributed web of observers, calling on anyone with a telescope, a radio dish, or open-source tracking software to log every flicker of light. Across Europe, groups like the Ibero Tracker Collective pooled wide-field sensor feeds. In Spain, Portugal, and beyond, private observers improvised, even experimenting with weather satellites and radio telescopes to bypass the blackout. Their goal, to ensure that at least someone, somewhere, sees what happens when these two anomalous objects sweep past the sun. In a sense, the story of Swan and Atlas has become as much about human ingenuity as it is about cosmic mystery. While official channels stay silent, citizen science may be the first to witness the unprecedented, keeping our eyes on the sky when the universe itself seems determined to hide its secrets.